Hello and welcome to our video for section 9.2's word problems. We skipped over these when we were covering 9.2 and 9.1, and we're going to kind of come back to it because it reviews a lot of the stuff in 9.1 and 9.2 as far as finding solutions, and gives us a chance to get ready for the quiz, which does have a word problem on it. Just fair notice, I will be typing in this video, so you will hear some clicking. I apologize in advance. You should have this note sheet in front of you. If you don't, ask the teacher to pause and grab one of these and continue when you're ready. We're going to start off with the way the word problems are set up, and the word problems are generally going to be looking for four things, three of which you can see here. They're always going to be dealing with time versus height. So I usually think of the ball goes in the air example. It's basketball season wrapping up, so you can think about a basketball, shoot a three-pointer, it goes up, it comes down. That's a parabola. Same thing with what else? Golf balls, footballs, pretty much any sport is going to have parabolas in it. It's going to involve a ball going up and coming down to some degree. Obviously, some those parabolas are going to be flatter than others, but if you graph it out, their height versus time is going to be parabolic. It's physics, so it's not math as much as it is science, but science is math. So there's a chance for us to see some of all this math actually show up in real life, even though obviously I don't expect you guys to pull out pen and paper every time you jack up a three. But if somebody were on the sidelines, they could, in theory, map out your three-pointer and predict where it was going to land based on the parabola that it formed. That's a lot of what we're going to be doing. But the first thing we'll be looking at is height versus time. Ultimately, what we want to see is what's the maximum height. That'll be one of the first things. And maximum height could and should sound to you like maximum value, and that's because it is. If you think about what we talked about in section 9.1, we had to find a maximum height. And I guess I should be clear, all of our parabolas in this example will be downward opening, so they're all going to start somewhere near the origin and come up and then come back down. So they'll all will be facing or opening downward. So they'll all have a maximum height, and we find it the same way that we've been finding it. The maximum height is k, so it's just k from the vertex. That's really all you need to write there. K from the vertex. That's how you figure out how high the ball is going in the problem. Now, of course, in order to find k, you have to find the vertex, and so you can use any of the tricks that we've talked about as far as finding the vertex on the calculator. You can look at the table and see if there's enough symmetry. Odds are, to get an exact value though for the vertex, you'll need to do the second calc maximum method. I'd like to walk you through that in this video, but I don't have that text set up, so you'll just have to remember and review your notes. But maximum height is k from the vertex. All right, it's that simple. You will be asked to find the axis of symmetry, which has some uses in real life, because we want to try and find how long it takes to reach the highest point, and that's what that would show us. And it would still just be a classic case of x equals h being the vertex coordinate for x. So we're still doing the same stuff. We're still finding the axis of symmetry with x equals h. We're still finding the maximum height with k. Nothing's changed. We're just going to be talking about it in a more realistic context. Finally, the last thing we'll be looking at is how long the ball, or whatever the object is, stays in the air, and also when does it land, which, if you think about it, those are pretty synonymous, right? I mean, if it goes up in the air and comes down, it's going to land at the same time that it stops being in the air. So you'll have the question asked in a couple different ways, but it's still looking for the same thing, and that is the x-intercept that you can see written here. Okay, you got to find the x-intercept. In other words, you have to find the solution. The idea is, again, the ball or whatever it is gets launched out of the air near somebody's foot or baseball bat or whatever it is, and after a couple of seconds, it's going to come back down. Our goal is going to be to find where that contact happens, where it comes back down to the ground. Okay, whether it's how long has it been in the air or when does it land. Ultimately, it's going to be trying to find that second rightmost solution. So if I'm taking my notes, I would really just write find the solution when y equals 0. Okay. And again, this is nothing we haven't done. Everything that we do with these word problems is what we had to do in section 9.1. The only difference is there's a word problem attached to it. So let's look at one of these examples. You'll see here that I've already pulled up the equation we're going to be using on Desmos, but we'll talk about what that parabola represents here in just a second. Let's read the first problem here on the note sheet that you've got. We have a goalie kicks a soccer ball with an upward velocity of 65 feet per second. The equation h equals negative 16t squared plus 65t plus 1 represents the height of the ball in feet after 10 seconds. So just like we set up here, we've got height versus time. How high is it given a certain amount of time? That's what we're looking at in the case with this soccer ball. Now, as I mentioned before, we're going to be dealing with maximum height of the ball, how long the ball is in the air, and how high that ball is in the air after 3 seconds. And we'll talk about how to find each of those. First, you're going to want to start off with the graph. A couple of things that I'm going to explain through Desmos and kind of let you guys work your way through on how to see this stuff on the calculator. Right now, I've got the equation negative 16x squared. You can see it right here, negative 16x squared plus 65x plus 1. There's my y equals. Obviously, all I've done is I've changed all the t's to x's. Nothing you guys wouldn't have done naturally. And then, yeah, this is the graph I get. Now, if you guys just type this into the calculator, though, what you're going to get is a really sharp vertical line, and it's going to come down about halfway down here at about x equals 4, because you guys have the calculator set up for Zoom Standard. What you'll need to do is you'll need to go into Window. Now, on Desmos, Window works like this. I say I want to see the x-axis from about -1 to about 5. I've moved it around a little bit, so that's where all the decimals are coming from. And for my y-axis, actually, let's go ahead and fix that. -1 to 5 in the x-axis, and the step on the calculators is it is x SCL for x scale, and we'll just set that to 1. And then for the y-axis, -10 to, let's say, 75. Okay, take a minute, pause the video, and play around with the calculators for a little bit. Go to the Window button, play around with x minimum, x maximum, so that your graph looks like mine. Again, we want to go, and I'll pull it up, we want to go from -1 to 5 for the x min and max, and from -10 to +75 for the y min and max. And our goal, we should have the x scale as 1 and the y scale as 1. All right, pause the video, take a moment, and try and get it so everybody's calculators are showing this equation with the window that I've got pictured here. Okay, so after you've got your graph set up to look somewhat like mine, and if it's not exact, that's okay. We're going to come back to the actual meat of the problem. Now, you'll notice there is a spot to graph, so you will need to, do your best to make this graph fit. You can go 1 second, 2 seconds, 3 seconds, 4 seconds, 5 seconds pretty easy and get a pretty good picture. But realize, just looking at this graph, it goes up to about 68, 70, somewhere in there. So if I just go 1, 2, 3, 4, I'm going to run out of space pretty quick. So you'll need to go maybe 5, 10, 15, or even 10, 20, 30 to make sure you give yourself enough room so that you can create a decent picture of this graph. It's not going to be perfect, but the sketch really will help you make less mistakes. Now, let's talk about how to find the maximum height of this ball. We've already mentioned that the maximum height will be k from the vertex, so we have to find the vertex. Now, I'm going to cheat because I'm using Desmos, and to find the vertex in Desmos, I just click on it, and there it is. That's the vertex. And obviously, for you guys to do this in the calculator, you will have to do that second calc maximum in this case, and set up your left bound at somewhere around 1, and your right bound probably at 3. Use the cursor to get somewhere to the left and right of the top of the hump. Press enter a couple times, and you should be able to get something very close to 2.031, 67.16. Once that's said and done, I'll click on here again. There it went. I just take the k value, and that's my maximum height. So I would just say the maximum height, oops, height of the ball is 67.016 feet. Now, I'm rounding to 3 decimal places here simply because that's what Desmos gave me, and it's already rounded, so I don't have to worry too much. On your calculators, obviously, it's going to give you probably 5 or 6 decimal places. We don't need all those. I'd say 2 decimal places would be a good number, so maybe your answer will say 67.02. But that's how we find maximum height. Okay, take a minute to pause the video and verify that you know how to do it on your calculator. Okay, hopefully you were just able to get it so that your calculator gave you the same answer that Desmos gave me here in this video. Now we have to talk about how long the ball is in the air. Now to find how long the ball is in the air, well, here's the ball. It starts off about, looks like 1 foot off the ground, which makes sense from where the goalie would kick it. And then it's going to go up, 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 up in the air, get about 67 feet in the air, then come back down, 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 down. And from looking at the graph, it looks like it's going to be about 4 seconds. And again, Desmos makes this so easy, it feels like cheating. But yes, we'll see right away, just from clicking on that point, it's going to take 4.078 seconds to reach the ground. And that's what I would have to write in. The ball, oops, the ball will be in the air for 4.078 seconds. And again, are we really going to need 3 decimal places? No, 2 will probably be fine. 1 might even be fine. I'd probably accept, although I like 2. But yeah, it's really easy to do this on Desmos. Where's the challenge? The challenge comes in using the calculator. So again, pause the video, take a minute to verify that you can get the same answer that I just got using the second calc 0 function to find this 4.078 answer. Now, the last thing you're going to be asked to do, I know that I mentioned axis of symmetry, but realize axis of symmetry will just be x equals 2.031. The problem that's on the quiz does ask for that, so just be aware of that. That's an option for another question I might ask. But this last one here, how high is the ball in the air after 3 seconds? That was actually pretty easy to find too. On Desmos, again, it's as simple as going about 3 over, finding that point, and clicking on it. So I got 2.99. I can get about 3.003, and that was 51 point, what was that, 97? There we go. 51.813 will be close enough, okay? And honestly, that's good enough. I would just say, let's see, 51.803. And I need to make a complete sentence. So the ball will be 51.803 feet in the air after 3 seconds. Okay. Now, how do you do that on your calculator? Well, you've got a couple of options. Option 1, go to the table. Second table and scroll up until x equals 3. Once x equals 3, the y value that's right there will be the height of the base, or the height of the soccer ball after 3 seconds. That's probably the easiest way. Another way is to try second calc, and instead of doing the other options, we just want a simple value. So second calc value, and type in 3, and the response will be the point at x equals 3, y equals approximately 51.803. So it's a fairly simple question. If you can't figure that out and the calculator is confusing you, go old school. Negative 16 times 3 squared plus 65 times 3 plus 1. That's literally all the calculator is doing. It's just plugging in a value for x to get you the answer that you're asking for. Okay? That is what we're going to be covering in this section. Now, what I want you guys to do is go ahead, answer number 2. Answer number 2 here asks slightly different questions. You've got a coin going up in the air, but it still wants to know how high the coin gets. It wants to know how much time it's going to take for the coin to land in the water. Okay, you're still looking for the vertex. You're still looking for the x-intercept. We're not doing anything new. We're just adding words on top of it. Okay. Don't forget about word problems. When you're done, complete the assignment, and I'll see you guys next time. Thanks for your cooperation. Make sure you write down any questions you have for me for the next time we get to see each other.